Hello friends, I am Professor Vaibhav Shah. Welcome to my channel. In today's lecture, lecture 18, we will be learning how to draw a cycloid. If you like my content and teaching style, then don't forget to like and subscribe to my channel to show your love and support. Now, let us begin. Step by step procedure to draw a cycloid. So, we will be following all of these steps to draw any of the cycloid. But before moving ahead, let us understand this word cycloid. So now, here cycloid word reminds us of a cycle in the first sense. So let us suppose this is nothing but a wheel of a cycle which has to roll over a straight path in the rightward direction, and we have to trace the path of any point P on this rolling wheel. Or in other words, let us assume that we have one wheel of a cycle which is rolling, and we will be tracing the path of its valve tube from which we used to fill in the air to inflate the tire. So this is the point which we can also call it as a valve tube in the case of your cycle's tire. So we will be simply tracing the locations of this valve tube point P in various positions like this, and it will generate the curve which is nothing but the cycloid. So let us start the procedure. So now we'll be given with the circle diameter or circle's radius. So we'll be always starting with either the diameter of a circle or a radius of a circle. So here let us assume in our case we are provided with a diameter of a circle. So first let us construct one circle with the given diameter d, and we'll identify its center as center point C, or you can always write as center point C0, which will denote the initial position of this circle. After drawing this circle, we'll be either dividing this circle into 12 number of equal parts, or we can also divide the circle into 8 number of equal parts. So let's say in our case, we have divided this circle into 12 number of equal parts. So you will be using 30 degree, 60 degree set square to divide this circle into 12 number of equal parts. Now, after dividing this circle, we'll start numbering from this point P, which will be your initial point. And as we know that we'll be tracing the end point of this valve tube. So let us suppose our initial point here is point P, and we have to trace the motion of or location of this point P, which is currently at this bottom position of your circle. So this is your starting point as 0. So you will just specify this point as 0. Then after we will start numbering from this rightward direction: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and back to initial point, which is now your point number 12. After dividing this circle into 12 parts, we have to draw one straight line from the bottom part of your circle. So you can also say we have drawn one tangent line from the bottom part of your circle. So let us draw this tangent line from the bottom part of the circle. Now, what would be the length of this line? So let us suppose we are tracing the path of this cycloid for one complete rotation or revolution of your circle. So if your circle rotates for one complete rotation, then we can say that it has traveled the distance of its circumference. So here the circle is of diameter d. So we can say that the circumference of this circle would be totally known as pi d. So we can draw this horizontal length of this line exactly equal to the circumference of the circle. So always remember, you have to draw this horizontal line or this tangent line length exactly equal to the circumference of your rolling circle. So now we have drawn this line of the length of circumferential distance. Now, as we know that we have divided the circumference of a circle into 12 equal parts, that means that we have to compulsorily divide this linear length of this line also into 12 parts. Why? Because this line length is exactly equal to your circumferential distance. So for that, we will be dividing this horizontal line also into 12 parts, like you can see. So we'll start numbering from this 0 point itself, because this line is connected with this circle at this point. So we can say this point is as 0 point. Now let us give numbering like this: 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and lastly 12 dash. Now, after drawing these points, we'll draw one horizontal line parallel to this tangent line from this center point C, which is also known as a center line. So let us draw one horizontal line from the center point C of exactly equal length of your tangent line passing from your point P. So we are drawn parallel line. For drawing this line, you have to simply use your roller scale or your drafter edge. So now, after drawing this line, we have to simply transfer point 1 dash vertically on that line to get our center C1. Similarly, point 2 dash vertically, transfer it on this horizontal center line to get C2. Likewise, we will transfer each of the points vertically upwards to get our points, center points C3, C4, C5, C6, C7, C8, C9, C10, C11, and C12. These points denotes the location of 12 different position of your circle or your center of your circle while it is rotating on this straight path on the rightward direction. Now, after that, we have to simply draw parallel lines to the center lines from your point number 111 like this. So this is your line which is exactly parallel to your center line. From point number 10 and 2, you will draw one line which will be exactly parallel to your center line once again. Now from point number 8 and 4, you have to draw one parallel line parallel to this center line like this. After that, you will draw one more parallel line from this point number 5 and 7. So like this, which will be always parallel to your center line. And once again, from your last top point 6, you have to draw one parallel line from this 6 itself. Now, this is a basic construction. So now, after that, what you will do? So after that, the procedure is very simple. So we are tracing the path of this point P. So let us understand. So what is the distance between this center point and path P? So you will say, obviously, sir, it will be the distance of radius. So yes, we are having this point P, which is the distance of radius away from your center point. So now we have to obviously trace the path of your point P. So for that, let us take the distance from the center to P on our rounder, because we will be tracing the point from the different centers. So now we'll be taking the radius of C to P, or you can say we'll be taking the radius of this rolling circle. So adjust on your rounder the radius of your rolling circle. So here the rolling circle radius would be this CP point. So adjust on your rounder the distance between your point C and P. Now, after adjusting your rounder CP distance, now this is your point C0. So we already have this point P. So let us denote the point P1 by center C1. So very simple, you have to select center C1 to locate your point P1, our very first point. So we have to select this center C1 and you have to cut this line of 1. So this is the line of 1, horizontal line of 1. So let us cut this horizontal line of 1 somewhere here. So we'll be having this point as P1. After that, select the center C2. You have to cut the line of 2 or line passing from your point 2. So put your rounder at C2 now and try to cut this line of 2 somewhere here to get this point P2 somewhere here on your P2 line. Now go to center C3 with the same radius of your rolling circle. Put your rounder at C3 and try to cut your line of 3. So this is the line of 3 which is also a center line. So try to cut this line somewhere here. So you will be having this point as P3. After that, change the center to C4 and this time we'll be cutting a 4 line. So this is point number 4. So there will be line of 4. So we'll be cutting this line of 4. So this is a 4 line, P4. So we'll be having this point as a P4. After that, let us change to center C5. So when we are at the center C5, we must cut the line of 5 or line passing from point number 5. So let us first locate this point 5. This is my point 5 and there is one line passing through this point 5. So whenever we are at the center C5, we must cut the line passing through this point number 5. So which will give us point somewhere here. This will be our point P5. After that, we'll be selecting center C6. So if we are selecting the center C6, which means we have to cut this line passing from this point 6. So this is point 6 and my line passing from this point 6 is this. So we have to cut the arc from this C6 center somewhere here to get this point P6. Now from C7, we have to cut the line of 7. So this is the line of 7. So we have to cut the line of 7 somewhere here to get the P7. From C8, we have to cut the line of 8. So this is point 8. So we have to cut the line of 8 here to get the P8. From C9, we have to cut the line of 9. So line of 9 is also the center line of this circle. So we have to cut this center line of circle, which is also the line of 9. So which will give us point here somewhere P9. After that, from C10, we have to cut the line of 10. So this is the point 10 and the line passing from the 10 will be this. So you have to cut this line from your center C10. After C11, from C11, we have to cut the line of C11. So C11 is this line. So you have to keep the same radius of your rolling circle and you will cut this line of 11 number point here from your C11 center to get your point P11. And likewise, you have to use your final center, which is C12. So C12, you will be drawing one arc on this 12 line. So 12 line is nothing but your tangent line itself. So you will be cutting this tangent line somewhere here to get your point number P12 somewhere here. So now, after getting these points, you have to simply connect all these points by a smooth curve, smooth dark curve, and you will be having this dark curve, which is nothing but your required cycloid. So now let us understand the terminology of the cycloid. So this line over which our wheel will rotate on the rightward direction is nothing but known as your directing line, which directs the motion or the rotational motion of the wheel. So now, after this wheel itself is known as rolling circle or generating circle. Why rolling circle? Because this circle rolls over this straight path or this directing line. That's why it is known as your rolling circle. And generating circle means this rotation of this wheel generates the curve known as cycloid. That means it is generating the curve. So it is also known as generating circle. And this is the symbol of your diameter. So phi means your diameter. So here phi is your diameter of this circle. So let us suppose our diameter is d. So our phi is here d. In our example, if the given is the diameter of 30 mm, so you can write down phi 30. So in this case, our diameter is d. So that's why we have simplified phi d. But in example, we'll see how to give the dimensions. So this is the basic procedure to draw a cycloid. Very easy. Yes. So let us begin and let us see examples based on this procedure. So now problem number 1. Draw locus of a point on the periphery of a circle which rolls on a straight line path. Take circle diameter as 50 mm. So here it is said that we have to trace out one point on circle which is rotating or rolling on a straight path, like previously we have seen. And here the circle diameter is given, which is nothing but your 50 mm. So that means your diameter is 50. So it is obvious that our radius would be 25 mm. So let us start. So first of all, what we will do? So first of all, we have to draw one circle with a given diameter. So here the diameter is 50 mm. So we'll be taking 25 mm as a radius on our rounder, and we have to draw one circle. After drawing circle, the second task would be to draw a tangent line. Now, once again, the tangent line would be exactly equal to the circumferential length of the circle. So in our case, if the diameter is 50, then this tangent line would be of our distance pi d, pi into 50, and whichever is the answer, you have to draw the straight line of that distance. So which is of a pi d in this case. Now, after that, we'll be giving the rotation direction of this circle. So don't forget to give the rotation direction of this circle. So in this case, our wheel has to rotate in rightward direction, which means that wheel has to rotate in clockwise direction. So we have given this direction as clockwise direction. Now, after that, we'll be dividing this circle into 8 number of equal parts in this case. So for this, you will be using 45-degree set square. So whenever you have to divide the circle into 8 number of equal parts, you have to use 45-degree set square. And if in this case, if you want to divide the circle into 12 number of equal parts, then you can always use 30-degree and 60-degree set square. So now we have divided this circle into 8 number of equal parts. After that, we have to give the numbering. So always start your numbering from this tangent point, so which will be your 0 point. So we'll define this point as 0. Now we'll start numbering from this point in clockwise direction: 1, 2, 3, 4, 5, 6, 7, and obviously this point would be your point number 8. So you have to define this point as point number 8. We will start from this point, so write it down here as 0, then 1, 2, 3, 4, 5, 6, 7, and 8. So you have to specify 0 and 8 in your case. So now, after that, we'll define our starting point. So whenever it is not given that which point we have to trace, we'll always take this point of intersection of your circle and your straight line as your starting point to be traced. So now, after that, you have to draw one line exactly parallel to this line, tangent line, so which will be constructing by your either by your ruler scale or by your drafter edge. After constructing the line parallel to this tangent line, this is your center line. So now, if we have divided this circle into 8 parts, that means that we have to divide this center line also into 8 parts. So let us divide this center line also into 8 parts to get 8 different centers of this circle. So we'll be dividing this center line into 8 number of equal parts. So 1, 2, 3, 4, 5, 6, 7, and 8. And finally is your center C0. You can call it C or C0. After that, let us give the numbering to these centers. So C1, C2, C3, C4, C5, C6, C7, and C8. Now after that, the procedure is very simple. We'll be drawing lines parallel to the center line from the point number 1 and 7, 3 and 5, and point number 4. So let us observe the procedure. We'll be drawing lines parallel to your center line. Let us draw line parallel to center line from your 1 and 7, now from your 3 and 5, and now we are from point number 4. Very easy. So now let us observe the next procedure. So in next procedure, we know that we have to trace the path of point P. And we know that this point P is at the radial distance away from your center point, so which is 25 mm in this case. So we have to adjust distance of CP, which is 25 mm radius, on our rounder for this example. So adjust your radius CP, or in other words, radius of 25 mm on your rounder. Okay, so you adjusted your radius 25 mm. Okay, done. So now let us start the procedure. So now put your rounder at center point C1, and whenever we are using center point C1, we'll try to cut the line of point number 1. So this is point number 1. We will try to cut this line of point number 1. So let us cut this line of point number 1 somewhere here. So we have cut this line of point number 1 here. We will get 1 point, which is nothing but your point number P1. Now let us use your center point number C2. So now with the same radius of 25 mm, let us cut the line of 2. So this is point 2, and the line of 2 is nothing but the center line itself. So while we are using point C2, we have to cut this line of 2 itself. So let us cut this line of 2 here. So we'll be having this point somewhere here. Similarly, when we are using the point C3 as a center, we have to cut the line of 3. So this is point number 3, and this is the line passing through this point 3. You have to use the same 25 mm, and you have to cut the C3 center to here, this line of 3, to get this point P3. After that, let us use C4 center. When we are using C4 center, it is obvious that we'll try to cut the line of 4. So this is nothing but the line of 4. So try to cut this line of 4 somewhere here. So we have cut this line of 4 somewhere here. After that, we'll be using center C5. So try to cut the line of 5 somewhere here, because this is the line of 5. So try to cut this line of 5 here. We have cut this line of 5 here. When we are using center C6, it is obvious that we have to cut the line of 6. But here, the line of 6 is also the center line. So we'll be cutting the center line somewhere here. Now for point number 7. So point number 7, when we are using C7, we have to compulsorily cut the line of 7. So this is the point number 7. So this is the line of 7. So let us cut the point number 7 somewhere here. And after that, the final point, C8, we have to cut the line of 8, which is nothing but your tangent line. So this is the point number 8's line, which is your tangent line. So you have to cut this line somewhere here. You have cut this line. So these are nothing but our points. So let us give the numbering to these points. So starting from this point, so P. So first identify these points by a dark marking points like this, so we can clearly understand where our points are. And after that, let us give the numbering: P1, P2, P3, P4, then P5, then P6, P7, and P8. So we are almost done. Now you have to join these points by a smooth dark curve. So let us join these points by a smooth dark curve like this, and another half like this. So your example is over. Very easy. So you have to simply follow this procedure in each of the examples to get the same result. So let us see one more example based on the same concept of cycloid. Problem 2. Diameter of the rolling or the generating circle is 60 mm. Construct the cycloid. Also draw tangent and normal to the curve at any point. Initial position of point P is at the point of contact between generating circle and the directing circle. So here, diameter of rolling or generating circle is given, which is 60 mm. So generating or rolling circle is nothing but our circle which will rotate on the straight line path. So this is our generating circle, or you can call it as our rolling circle. Now the diameter is given as 60 mm, so it is obvious that radius would be of 30 mm. So we will be using throughout the example radius which is fixed 30 mm. Construct the cycloid. So it is obvious that it would produce the cycloid. Also draw tangent and normal. So we will be learning tangent and normal in a separate lecture. So in this example, we will not be focusing on tangent and normal. We'll look at in the different lecture. Now, initial position of point P, here it is given that initial position of point P, so is at the point of contact between generating circle and the directing line. So this is your generating circle and this is your directing line. So the point of contact means the intersection point of your directing line and generating circle. So this will be the initial position of your point P. So we have marked this position as P0 or initial position of point P. In the different example, it can be asked that the initial position of your point P is at the top of the circle or on the leftmost side of your circle or on the rightmost side of the circle. So provided to that examples, your solution may differ. So in this case, our initial position is at the intersection point of your tangent line and your generating circle. So this is your initial position. So let us mark this position as P0. Now, let us begin. So first of all, we have to draw one circle once again. Here in this case, our radius would be of a 30 mm because our diameter is 60 mm. That means we have to draw one circle of 30 mm. Now, after drawing your circle, we'll identify its rotation direction as clockwise direction. Now, why clockwise direction? Because our circle has to rotate in rightward direction. So that's how our circle has to rotate in clockwise direction only. After that, we will divide this circle into either 8 number of equal parts or 12 number of equal parts. So for our case, we will be dividing this circle into 8 number of equal parts. So let us divide this circle into 8 number of equal parts, and after dividing this circle, we'll give the numbering. So let us give numbering like this. Starting point would always be 0.1, 2, 3, 4, 5, 6, 7, and once again return to the initial position. So let us call this point as A. Now, after that, we have to draw one straight line from the bottom of this part, which must be the tangent point to this circle. So we have drawn one straight line. The length of this straight line will be of a circumferential distance of this circle. So in our case, our radius is 30 mm. So that means that our circumferential distance would be 2 pi r. So 2 pi into 30, whichever is your distance, you can draw the straight line of that measurement. In other words, you can always use pi d distance. So here our diameter is 60 mm. So you can always use pi into d. So pi into 60, and whichever is your answer, you can draw the line of that measurement. Now, as we have divided this circle into 8 number of equal parts, so we have to compulsorily divide this straight line also into 8 number of equal parts. Why? Because both the lengths are of a circumferential distance of the circle. So now after drawing this line into 8 number of equal parts, we have to give the numbering from the starting point 0, 1, 2, 3, 4, 5, 6, 7, and 8. Now, after that, very easy, we have to draw the center line from this point. Now, in this case, we have defined this center point as C0. In your example, you can either define this point by C0 or simply by point C. So now we have drawn the center line exactly parallel to this tangent line. After drawing this center line, we have to draw vertical line from this point 1 to locate the center point C1, vertical line from 2 to center point C2, vertical line from 3 to locate the center point C3, vertical line from point 4 to locate this center point C4, vertical line from this point 5 to locate C5, likewise C6, C7, and C8 would be located. Now, next step, we have to draw parallel lines to your center line from your point 7,1 like this. Draw one line from your 5,3 which must be parallel to your center line like this, and draw one more line from your point 4 which must be a parallel line to your center line. So you will be using your roller scale or your drafter aids to draw parallel lines through 1, 7, 5, 3, and 4. Now after drawing these parallel lines, you will select on your rounder the dimension of the radius of this rolling circle, so which is C0 P0 in our case, or you can take 30 mm directly on your rounder. After selecting this radial distance on your rounder, use your center C1 and try to cut the line of 1. So this is point 1. So this is the line of 1. So you have to cut the line passing from 1 somewhere here to get point P1. Now use your center C2. Try to cut the line of 2. So this is point number 2 and this is the line of 2, which is also the center line. So try to cut this line somewhere here. We will be having this point as P2. Use center C3. Try to cut the line passing through this C. So here we'll try to cut this line somewhere here. So we'll be having this point P3. From point C4, try to cut the line passing from your point 4. You will get your point P4 somewhere here. From C5, try to cut the line passing from this point 5. So this is point 5 and this is the line of 5. So if we try to cut this from the center C5, this line somewhere here, so we'll be having this point C5. Now from point C6, try to cut the line of 6, which is also center lines. You will get this point P6 somewhere here. From point C7, try to cut the line of 7. This is line of 7. You will have this point here as P7. And from final point C8, try to cut the point of line of 8. So this is final point 8. So this is the line of 8. So you will cut this line of 8 somewhere here to get this point E8. After getting all these points P0, P1, P2, P3, P4, P5, P6, P7 and P8, you have to simply join these points by a dark smooth curve like this to get your required curve, which is nothing but your required cycle. So very easy, similar process, the diameter is only the change. So that is all from my side. I hope you liked my content. So if you like my content, then don't forget to like, share and subscribe to my channel to show your love and support. Keep learning, stay connected. Bye-bye.